Okay, so for our enrichment topic, we need to prove that the slopes of perpendicular lines are negative reciprocals of each other. Okay, so have you ever wondered why the slope of perpendicular lines are negative reciprocals of each other? Because we know that the parallel lines, when two parallel lines are on a plane, so they must have the same slope in order for those two parallel lines to be parallel. But for for perpendicular lines, the slopes of the two perpendicular lines must be negative reciprocals of each other. So have you ever wondered why is that the case? Okay, so let's try to prove why the slope of these two lines are negative reciprocals of each other. So given line 1 is perpendicular to line 2, where m sub 1 is the slope of line sub 1 or L sub 1 and m sub 2 is the slope of L sub 2, so we need to prove that the slope of line 1 is equal to the negative reciprocal of the slope of line 2, where the slope of line 1, okay, which is m sub 1, times the slope of line 2, which is m sub 2, is equal to negative 1. Okay, so how do we try to make a proof for that? Okay, so this is kind of like the proof that we have. Okay, so we state first the given. Okay, the given is that L sub 1, okay, line 1 is perpendicular to line 2 with vertical line at x is equal to 1. Okay, so we drew here a perpendicular line which is x is equal to 1, and where m sub 1 is equal to the slope of L sub 1 and m sub 2 is equal to the slope of L sub 2. Then the vertical line, at the vertical line x is equal to 1 intersects at L sub 1 at 1, okay, m sub 1 and L sub 2 at 1 m sub 2. So essentially we have these two numbers that we plotted here. Okay, so let's say for example this is 1 and this is negative 1. Okay, and therefore they have a coordinate which is 1. Okay, and then the value of their slope m sub 1, and then we have your negative 1 and the value of the slope of the second line which is m sub 2. Okay, and after that, okay, so the proof or the reason for that is run becomes the horizontal distance. Okay, so rise is the vertical and run is the horizontal, so that becomes the rise over run formula that you have been introduced with, or been introduced with when you were in grade 7 on your linear equations topic. Okay, so that's rise over run, so that's for the slope of the two lines. Okay, and then we have here for our first statement, FEH is a right angle. Okay, so where is FEH? Okay, so we have here FEH, so this angle is actually a right angle. It measures 90 degrees. So why is that? Because one of the properties of perpendicular lines is that when they meet, of course, they make 90-degree angles. So therefore, FEH is a right angle. And therefore, we can say that triangle FEH is a right triangle because it has a right angle. Okay, so we have these two statements and two proofs here checked. And then we can use the distance formula. If you can recall the distance formula, d is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, so if we can recall this formula, so this is used for finding the distance between 2 points. Okay, so we have here FE and EH. Okay, FE, okay, line segment FE, okay, and line segment EH. So we want to try to find the distance of those two segments. Okay, and therefore to solve for the distance of those two segments, we can equate it to the distance between F and H, between points F and H. Okay, so that line segment right there, which is equal to 1 minus 1 squared plus m sub 1 minus m sub 2 squared, okay, which is essentially equal to m sub 1 minus m sub 2. Okay, so that means line segment FH is equal to m sub 1, okay, m sub 1 minus m sub 2. And if we look closely, okay, we can use the Pythagorean theorem for this triangles right here. Okay, we have here triangles FEH, okay, triangle FEH. Since it's a right triangle, therefore we can use the Pythagorean theorem to solve for the side measurements, or to identify specific properties between those side measurements. So that's going to be 1 plus m squared, m sub 1 squared, and then that quantity, the square root of that, square root plus m sub 1 squared, okay, quantity squared, plus the square root of 1 plus m sub 2 squared, and then quantity squared is equal to m sub 1 minus m sub 2 squared. Okay, so that came from the line segment FE. Okay, so we added the line segment FE squared plus line segment EH squared. That will be equal to the hypotenuse, which is equal to FH. Okay, the FH there is the hypotenuse, and it's equal to FH squared. And that's why we squared m sub 1 minus m sub 2 using the Pythagorean theorem. Okay, so again, this is a right triangle. So and if we have a right triangle, we can use the Pythagorean theorem. So this becomes the a squared, this becomes the b squared, and this becomes the c squared. And from there, we got this formula right here on number 6. And then we're going to try to simplify this formula that we have here. So we have here 1 plus m sub 1 squared plus 1 plus m sub 2 squared is equal to m sub 1 minus m sub 2, the difference between the two slopes, and then we square that. So that's the squaring of a square root. The square root was cancelled. And from here, we can simplify more terms. So we have 2 plus m sub 1 squared plus m sub 2 squared is equal to m sub 1 squared minus 2 m sub 1 m sub 2 plus m sub 2 squared. Okay, so it's kind of like rearranging. Okay, we rearranged this formula that we have here because we computed for a binomial. Okay, so what we have here is we squared this binomial, m sub 1 times m sub 2, and we got m sub 1 squared minus 2 times m sub 1 times m sub 2 plus m sub 2 squared. Okay, and from there, okay, we can use the subtraction property of equality to get 2 is equal to negative 2 m sub 1 m sub 2, because these two cancel out. Okay, so 2 is equal to okay, so m sub 1 squared plus m sub 2 squared cancels out, and that will give you 2 is equal to negative 2 m sub 1 m sub 2 using the subtraction property of equality. And by dividing both terms by essentially 2, okay, if we divide both terms by 2, we get here that negative 1, okay, negative 1 is equal to m sub 1 times m sub 2. And therefore, we got this formula that right here, so that's equal to negative 1 is equal to m sub 1 times m sub 2 by using the multiplicative inverse property of equality. So that's simply, we multiplied this entire term here, 2 is equal to 2 minus m sub 1 times m sub 2 to negative 1 half. Okay, so that's how we got negative 1 here, and here we got m sub 1 m sub 2 because we've canceled out negative 2 here. And if we divide m sub 2 on both terms, we get that m sub 1 is equal to negative 1 all over m sub 2. And from there, we've proven the problem, okay? We've solved the problem, and we've proven that the slope, okay, the slope of a perpendicular line of two perpendicular lines are negative reciprocals of each other. So that's m sub 1 is equal to negative 1 all over m sub 2.